May 30th, 1942, New Orleans, Louisiana. Andrew Jackson Higgins stood in his small shipyard office, staring at a telegram from the Bureau of Ships. The message was brief, but carried the weight of potential catastrophe. The United States Navy needed landing craft capable of delivering an entire army directly onto hostile beaches. They needed thousands of them, and they needed a design that didn't yet exist. At that moment, the Allied war planners faced an impossible mathematical problem. Any invasion of occupied Europe would require putting approximately 150,000 men ashore within 24 hours. Traditional naval doctrine said this couldn't be done. Troops had to be ferried from transport ships to beaches in small boats, then transferred to smaller boats still to reach shore. The process took days, sometimes weeks. The Germans would have time to concentrate forces and annihilate any landing before it could establish a foothold. What neither the Navy nor Higgins fully understood was that their meeting would solve a problem that had plagued military planners since ancient times. How do you move an army across water and put it directly into combat without pause, without vulnerability, without the deadly delay that turns soldiers into targets? The solution would come from a loud-mouthed boat builder from Nebraska who had never finished high school, never served in the military, and whose primary customers before the war were fur trappers operating in Louisiana swamps. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The problem began with fundamental limitations of naval architecture. In May 1942, the United States Navy owned exactly 0 purpose-built landing craft capable of putting a tank directly onto a beach. The British had developed the landing craft mechanized, a 45-foot vessel that could carry 1 tank or 100 troops. But the LCM had to beach at high tide, required relatively gentle beaches, and could only be built in specialized shipyards at a rate of perhaps 3 per month. The British also operated the landing craft Assault, a smaller boat carrying 35 troops. The LCA was slow, had minimal armor, and crucially, featured high sides that troops had to climb over while under fire. Newsreel footage from the disastrous Dieppe raid in August 1942 would show Canadian soldiers trapped in LCAs, unable to exit quickly, cut down by German machine gun fire while still in their boats. The mathematics of invasion were brutally simple. Operation Overlord, still in early planning stages in 1942, would eventually require landing approximately 156,000 Allied troops on D-Day alone. Using existing British landing craft at their proven production rates, the Allies could build perhaps 300 new boats over the next 2 years. 300 landing craft could deliver approximately 30,000 troops per tide cycle. To land, 150,000 troops would require 5 separate tide cycles, meaning 3 days minimum. The Germans would have 72 hours to respond. The invasion would fail before it properly began. Vice Admiral John Leslie Hall, who would eventually command amphibious forces at Omaha Beach, understood the problem with brutal clarity. His internal memoranda from 1942, declassified in the 1970s, revealed the Navy's desperation. Our current landing craft are adequate for small-scale raids, but completely inadequate for the invasion we must eventually mount. We need vessels that can be built by the hundreds, operated by minimally trained crews, and capable of putting troops directly onto beaches under fire. Most critically, we need landing craft with bow ramps that allow rapid exit. British designs requiring troops to climb over gunwales are death traps. We need something entirely different. The Navy's Bureau of Ships had been working on landing craft designs since 1941, but every proposal faced the same obstacles. Boats capable of beaching required shallow drafts, meaning flat bottoms. Flat-bottomed boats were slow and handled poorly in open water. Boats large enough to carry meaningful cargo required powerful engines and sophisticated construction. Powerful engines and sophisticated construction meant specialized shipyards and trained craftsmen. The production timeline stretched to years, not months. Then, someone remembered Andrew Higgins. The Bureau of Ships had actually rejected Higgins's landing craft proposals multiple times between 1938 and 1941. His boats were considered too crude, too unconventional, too different from accepted naval architecture. But by May 1942, desperation had replaced convention. Andrew Jackson Higgins was born in Columbus, Nebraska in 1886. He entered the lumber business in his 20s, moved to New Orleans in 1930, and established Higgins Industries to build shallow draft boats for oil exploration companies and fur trappers. The company's specialty was vessels that could navigate Louisiana's swamps and bayous, waters rarely more than 3 feet deep, choked with vegetation and obstacles. Higgins's boats used a revolutionary hull design he called the spoonbill bow. Traditional boat design featured sharp prows that cut through water. This worked beautifully in deep water but was useless in shallows where the bow would embed in mud. Higgins reversed the logic entirely. His boats had wide, flat, tunnel-shaped hulls that rode over obstacles rather than cutting through them. The design looked absurd to trained naval architects, but worked perfectly in environments where conventional boats failed. By 1939, Higgins was building what he called Eureka boats for the Marine Corps. These were shallow draft vessels that could carry troops into swampy terrain. The Marines loved them. The Eureka could operate in 18 inches of water, beach itself on mud banks, reverse off without assistance, and survive impacts that would cripple conventional boats. But the Eureka had one fatal limitation. It had no bow ramp. Troops had to climb over the sides. In May 1942, when the Bureau of Ships finally contacted Higgins about landing craft production, they explained the requirement. They needed a boat combining the Eureka's shallow draft capabilities with a bow ramp that could drop instantly, allowing troops to charge directly onto beaches. Such a design had never been built. Higgins told them he could have a prototype ready in 3 weeks. The Navy was skeptical but authorized the attempt. What happened next would become legendary in naval circles. Higgins didn't design a new boat. He modified an existing one. He took an Eureka hull, cut off the bow, and installed a retractable ramp held up by 2 steel cables operated by a simple winch. The modification took exactly 17 days. On June 16, 1942, the first Higgins boat with a bow ramp conducted trials in Lake Pontchartrain. The demonstration was characteristically Higgins. Rather than carefully presenting technical specifications, he loaded the boat with his own workers, drove full speed toward the shore, dropped the ramp while still moving, and had his men pour off the front while the boat was beaching. The entire evolution took approximately 30 seconds. The Navy observers were stunned. Traditional landing craft took minutes to discharge troops. The Higgins boat did it in half a minute. But speed wasn't the only advantage. The bow ramp meant troops exited facing forward, weapons ready, able to immediately engage targets. In British landing craft, soldiers climbed over sides, vulnerable and disoriented. The tactical difference was profound. A boat carrying 36 troops could put all 36 onto the beach in combat formation in under 45 seconds. Machine gun positions had barely enough time to acquire targets before infantry was off the beach and moving. The Navy authorized immediate production. The Bureau of Ships ordered 20 boats initially, then 50, then hundreds as testing continued through summer 1942. By September, Higgins Industries was building landing craft at a rate exceeding all British production combined. The boat that would become designated LCVP, Landing Craft Vehicle Personnel, was 36 feet long, 10 feet wide, drew just 3 feet of water aft and 2 feet forward, and could carry either 36 troops or 8,000 pounds of cargo. The construction was revolutionary in its simplicity. The hull was built from standard marine plywood over a framework of simple wood stringers. No complex curves, no difficult joinery, no specialized skills required. The sides were protected by armor, plate, 1/4-inch steel sufficient to stop rifle bullets and most shell fragments. The bow ramp was steel plate operated by a simple cable and winch mechanism requiring no hydraulics or complex machinery. The engine was a grey marine diesel, basically a Chevrolet truck engine converted to run on diesel fuel. It produced 225 horsepower, pushed the boat to 9 knots loaded, and could be maintained by anyone with basic mechanical skills. What made the design brilliant was not sophistication, but the complete opposite. Every component was simple, robust, and easy to manufacture. The plywood hull could be built by carpenters, not shipwrights. The armor plates were flat steel, requiring no forming. The ramp mechanism used hardware available in any industrial supply catalogue. The engine was a truck motor. A competent crew could build a complete LCVP in approximately 3 weeks using ordinary workshop tools. Rear Admiral John Wilkes, Commandant of the Charleston Navy Yard, inspected the first production LCVPs in October 1942. His official evaluation report captured the Navy's astonished recognition. Higgins has achieved what we thought impossible. He has created a landing craft requiring no specialized shipyard facilities, no rare materials, no highly trained workers, and no complex manufacturing processes. These boats can be built anywhere there is wood, steel, and people willing to work. The implications for production are staggering. We can build thousands where we expected to build hundreds. The transformation from prototype to mass production happened with remarkable speed. Higgins Industries expanded its New Orleans facilities throughout late 1942 and early 1943. By March 1943, the company operated 7 separate plants in New Orleans, employing over 20,000 workers. More significantly, Higgins licensed the design to boat builders across America. Small boat yards that had built fishing vessels and pleasure craft received detailed construction plans and began producing LCVPs. By mid-1943, LCVPs were being built in Louisiana, Florida, California, New York, and a dozen other states. The distributed production model meant bombing one factory wouldn't significantly impact total output. The simplicity of construction meant yards could start production within weeks of receiving plans. The standardization of components meant parts were interchangeable. An LCVP built in New Orleans could be repaired using components from boats built in California. The workforce transformation paralleled the Liberty ship experience. Higgins Industries employed women in unprecedented numbers for wartime shipbuilding. By 1944, women comprised over 50% of the New Orleans workforce. African Americans held skilled positions, including welding, machining, and assembly work. This level of integration was unusual for the Deep South in the 1940s, but Higgins cared only about production numbers. The workers themselves were largely unskilled before employment. Housewives, recent high school graduates, farmers, and clerks learned boat building from scratch. The training program was characteristically direct. New workers spent 1 week learning their specific operation, whether installing bulkheads, fitting armor plate, or wiring engines. They then moved to production lines where they performed that single operation repeatedly. Specialization allowed rapid training and high productivity. A riveter didn't need to understand the entire boat, only how to install rivets correctly in the specific locations assigned. This approach horrified traditional boat builders who believed craftsmen needed comprehensive knowledge. But the results were undeniable. By mid-1943, Higgins Industries was completing 1 LCVP every 90 minutes during peak production, a rate that would have seemed physically impossible by traditional boat building standards. The parallel development of the landing craft mechanized Mark III provided the heavy lift capability that complemented the LCVP. While the LCVP carried troops, the LCM-3 carried vehicles. The LCM-3 was 50 feet long, could carry 1 Sherman tank or 60 tons of cargo, and used the same spoonbill bow and bow ramp design as the LCVP. Critically, the LCM-3 was also designed for mass production using similar principles. The hull was welded steel rather than plywood, but the construction remained simple. Flat plates, basic welds, minimal compound curves. The engines were 2 grey marine diesels, basically 2 truck engines. The bow ramp was larger but operated on the same simple cable and winch principle. A competent crew could build an LCM 3 inches, approximately 6 weeks. By 1944, American yards were producing LCM 3 seconds at rates exceeding 2 per day across all facilities. The strategic impact became clear during Operation Husky, the invasion of Sicily, in July 1943. This was the first large-scale amphibious operation using primarily American landing craft. Over 2,000 Higgins boats participated in the initial assault. The results validated everything Higgins had promised. Troops hit beaches rapidly, under fire but able to immediately engage. Casualties during the landing phase were significantly lower than predicted. The boats survived rough seas, mechanical stress, and combat damage better than expected. Maintenance proved simple enough for minimally trained crews, but perhaps most importantly, the sheer numbers overwhelmed German defenders. When 2,000 landing craft can hit multiple beaches simultaneously, defenders cannot concentrate fire effectively. The tactical advantage of numbers had been enabled by Higgins's design for mass production. General Dwight Eisenhower, observing the Sicily landings, immediately grasped the implications. His correspondence from July 1943 revealed his recognition that landing craft quantity had become as important as landing craft quality. The Higgins boat has solved our fundamental problem. We can now put troops ashore faster than the enemy can react. This changes amphibious warfare completely. Instead of careful, cautious landings, vulnerable to concentrated defense, we can now launch overwhelming assaults across broad fronts. The landing craft themselves have become weapons through sheer numbers. By November 1943, the full scale of landing craft production had reached numbers that would have seemed fantastical just 2 years earlier. Higgins Industries alone had produced over 12,000 LCVPs. When combined with licensed production from other yards, American factories were completing approximately 700 landing craft per month. The logistical challenge had shifted from building enough boats to deploying them effectively across 2 oceans. The planning for Operation Overlord, the invasion of Normandy, began in earnest in late 1943. The operation would be the largest amphibious assault in human history, and landing craft formed the absolute foundation of the plan. Without sufficient Higgins boats, D-Day simply could not happen. The mathematics were staggering and unforgiving. The initial assault would require landing approximately 50,000 troops on 5 beaches within the first few hours. Supporting waves would bring another 100,000 troops, plus thousands of vehicles, artillery pieces, and tons of supplies. All of this had to cross the English Channel, navigate tidal currents, survive German obstacles and gunfire, and discharge directly onto hostile beaches. The Higgins boat was the only tool that made this remotely possible. Lieutenant General Frederick Morgan, the initial chief planner for Overlord, wrote in his December 1943 assessment that the landing craft had fundamentally changed what was militarily achievable. We are planning an operation that would have been dismissed as impossible in 1940. The difference is not better soldiers or superior tactics. The difference is landing craft. Specifically, it is the Higgins boat. Without these vessels, we would be planning an entirely different war, one focused on peripheral operations rather than direct assault on Fortress Europe. The challenge facing planners was not just the initial assault, but the sustained build-up required afterward. Intelligence estimates suggested the Allies would need to land approximately 500,000 troops within the first week, plus 20,000 vehicles and 100,000 tons of supplies. Until the Allies could capture and repair a deep-water port, every man, vehicle and bullet would have to come across beaches via landing craft. The solution was a logistics system of breathtaking scale. Over 5,000 landing craft of all types were assembled in England by spring 1944. Of these, approximately 1,500 were Higgins LCVPs, with another 1,000 LCM 3 seconds. These boats would operate in continuous cycles, ferrying loads from transport ships to beaches, returning for more loads, operating around the clock regardless of weather or enemy fire. The training program for landing craft crews reflected the urgency and scale of the operation. Young sailors, many of whom had never seen the ocean before joining the Navy, received approximately 6 weeks of training before taking command of their own Higgins boat. The training was intensely practical: navigation, beach recognition, obstacle identification, damage control, and the critical skill of beaching under fire while maintaining control. Ensign James Thompson, who commanded LCVP 2247 on D-Day, described his training in post-war interviews. "They taught us to drive these boats like they were trucks, hard and fast, straight at the beach, no hesitation. The worst thing you could do was slow down or stop. German gunners needed time to range in. Speed was your only protection. We practiced beaching runs until we could do them in our sleep. Full throttle to the beach, drop ramp the instant you hit sand, troops off in 30 seconds, reverse thrust, get off the beach. The whole evolution took maybe 2 minutes if you did it right." The boats themselves underwent modifications based on combat experience from Sicily and subsequent operations in Italy. Additional armor protection was added around the coxswain's position after too many boat commanders were killed by small arms fire. The bow ramps were reinforced after some failed under heavy vehicle weight. Extra pumps were installed after several boats took on water from near-miss explosions and sank, but the fundamental design remained Higgins's original concept: simple, rugged, mass-producible. The genius was that improvements could be incorporated without stopping production. Yard-building boats in March 1944 would implement armor upgrades without changing the basic hull construction. The standardization meant any crew could operate any LCVP, regardless of which yard built it or when. The pre-invasion build-up in England created scenes that seemed impossible. Small English coastal towns found themselves hosting hundreds of landing craft. The boats were literally parked in fields, harbours overflowed with them, and rivers held them in long floating chains. Maintenance crews worked around the clock, ensuring engines ran, ramps functioned, and hulls remained watertight. The sheer scale of the landing craft fleet meant that individual boats became almost anonymous. LCVP 2247 was functionally identical to LCVP 3891, which was identical to thousands of others. This anonymity was precisely the point. The boats were designed to be interchangeable parts in a massive machine. If one boat was damaged or destroyed, another immediately took its place. The system was designed to survive attrition. June 5, 1944. Weymouth Harbour, England. Thousands of landing craft loaded troops in. The late afternoon, preparing for the crossing to Normandy. The weather was marginal, with rough seas and overcast skies. But Eisenhower had made the decision. The invasion was on. The crossing took most of the night. The small landing craft, designed for short trips from ship to shore, were instead making a journey of over 100 miles across the English Channel. The seas were rough enough that many boats took water over the bow. Troops, already terrified about the coming battle, became violently seasick. Some boats developed mechanical problems and had to be towed, but the vast majority pressed on through the darkness toward the French coast. At 0630 hours on June 6, 1944, the first wave of Higgins boats hit the beaches of Normandy. What happened next would determine the fate of the war in Europe. Omaha Beach became the focal point of the entire operation, and initially it appeared the invasion might fail there. The first waves of troops landing from Higgins boats encountered withering German fire. Machine guns positioned in concrete bunkers swept the beach. Artillery zeroed in on landing craft as they approached. The boats themselves became targets, with German gunners specifically aiming at the vulnerable moments when ramps dropped and troops attempted to exit. Many boats took direct hits before reaching the beach. Shells penetrated the thin armor, killing or wounding everyone inside. Other boats hit underwater obstacles, tearing open hulls and sinking in deep water. Troops laden with heavy equipment drowned before reaching shore. Some boats, their coxswains killed or wounded, drifted aimlessly or collided with obstacles. But the Higgins boats kept coming, wave after wave, hundreds of boats, delivering troops relentlessly despite casualties. This was the fundamental genius of the design finally revealing itself under the worst possible conditions. The boats were expendable. Losing 10 boats meant nothing when hundreds more were available. Losing 50 boats was an acceptable cost if troops continued reaching the beach. The German defenders, for all their prepared positions and fields of fire, could not stop the sheer volume of the assault. Every minute brought more Higgins boats. Every boat brought more troops. The defenders could kill individuals, destroy individual boats, but they could not stop the mass. By mid-morning, despite horrific casualties, American troops had established footholds on Omaha Beach. By afternoon, they were moving inland. The other beaches told similar stories with less drama but equal importance. Utah Beach saw relatively light casualties, with Higgins boats delivering troops efficiently and withdrawing for more loads. The British and Canadian beaches at Gold, Juneau, and Sword experienced varied resistance. But in every case, the landing craft performed as designed. They put troops ashore quickly, survived or accepted damage, and maintained the flow of forces onto French soil. The statistics from D-Day revealed the scale of the landing craft operation. Over 1,300 Higgins LCVPs participated in the initial assault. These boats made multiple trips, with some completing 5 or 6 runs between transport ships and beaches. By the end of June 6th, approximately 34,000 troops had been landed via LCVP, along with thousands of tons of equipment and supplies. Casualties among landing craft crews were significant but not catastrophic. Approximately 60 LCVPs were destroyed or damaged beyond repair on D-Day itself. Several hundred more sustained damage but remained operational. The attrition rate was roughly 5%, well within acceptable parameters for an operation of this scale. More importantly, the loss of boats did not significantly impact the operation. Replacement craft were already on their way from England. The days following D-Day demonstrated the true value of the Higgins boat's design philosophy. The initial assault was spectacular and historic, but the sustained build-up that followed was equally critical. The Allies needed to land hundreds of thousands of additional troops and establish a logistics base capable of supporting offensive operations into France. For weeks after D-Day, Higgins boats operated continuously on a shuttle schedule that would have destroyed more delicate craft. Boats ran 24 hours a day, often overloaded, frequently under fire, operating in weather conditions that would normally ground small craft operations. Engines ran without proper maintenance. Hulls took repeated poundings on beaches. Crews worked to exhaustion. The boats kept functioning. The simple, rugged design proved nearly indestructible under operational conditions. When engines failed, they could be replaced with truck motors from supply depots. When hulls were damaged, any crew with welding equipment could patch them. When ramps jammed, simple mechanical repairs restored function. The boats were brutally maintainable, because they were brutally simple. By the end of June, 1,944, over 500,000 troops had been landed in Normandy. The vast majority arrived via landing craft, with Higgins boats accounting for the largest single share. The logistics operation had succeeded beyond the most optimistic projections. The Allies had established a secure beachhead, captured key objectives, and begun the campaign to liberate France. Andrew Higgins himself visited Normandy in July 1944, touring the beaches and meeting with Navy crews operating his boats. The visit was characteristically brief and unsentimental. Higgins inspected boats for damage patterns, asked crews about operational issues, and took notes on potential improvements. He spent more time talking with mechanics than with officers, more interested in practical engineering problems than in glory or recognition. One story from that visit captured Higgins's personality perfectly. A young Navy ensign, commanding an LCVP that had made over 40 trips to the beach, proudly showed Higgins his boat and detailed its combat service. Higgins examined the craft carefully, noted the various patches and repairs, then pointed to a weld on the bow ramp that had cracked. "That's a poor weld," he said. "When you get back to depot, have them re-weld that properly. 45-degree angle, full penetration. That's how it should be done. Then he moved to the next boat. No praise, no congratulations, just practical critique focused on making the next boat better. The European theatre continued to require landing craft through 1944 and into 1945. Operation Dragoon, the invasion of southern France in August 1944, used over 1,200 landing craft. The Rhine River crossings in early 1945 required hundreds of LCVPs to ferry troops across under fire. Every operation proved again that the Higgins boat could perform under any conditions. But the Pacific Theatre provided an even more demanding test of the design. The island-hopping campaign against Japan required amphibious assaults across thousands of miles of ocean against heavily fortified positions, often on coral atolls with treacherous reefs and surf conditions. The Higgins boat would face challenges in the Pacific that made Normandy look simple by comparison. The Pacific War was, in many ways, the natural environment for the Higgins boat. Every advance required an amphibious landing. Every island had to be taken from the sea. There were no alternatives, no land routes, no way to avoid putting troops directly onto hostile beaches. The entire American strategy for defeating Japan depended absolutely on landing craft capability. The Battle of Tarawa in November 1943 revealed critical lessons that would shape Pacific operations. The initial assault used primarily British-designed landing craft, which grounded on reefs hundreds of yards from shore. Marines had to wade through chest-deep water under heavy fire. Casualties were catastrophic. The operation succeeded, but barely, and at terrible cost. Tarawa proved that shallow draft landing craft were essential for Pacific operations. The Higgins boat, with its 2-foot forward draft, could navigate over reefs that stopped other craft. Moreover, the spoonbill bow design allowed Higgins boats to ride over coral obstacles that would rip open conventional hulls. The Pacific Islands, with their coral reefs and complex surf conditions, became the ideal testing ground for Higgins's original swamp boat concepts. The next major operations, from Kwajalein through Saipan, Guam, and Tinian, increasingly relied on Higgins boats as the primary assault craft. The boats proved they could handle not just reefs but also the intense surf conditions common in the Pacific. The flat-bottomed design, initially developed for Louisiana swamps, turned out to be perfect for riding over Pacific swells and punching through surf zones. By mid-1944, the Pacific amphibious assault had become a refined system with Higgins boats at its core. The typical operation involved hundreds of LCVPs operating from transport ships positioned miles offshore. The boats would form up in waves, coordinate their approach timing, and hit the beach simultaneously across a broad front. The sheer numbers overwhelmed defenders, exactly as Eisenhower had recognized at Sicily. Iwo Jima and Okinawa represented the culmination of Pacific amphibious doctrine. Both operations required landing over 70,000 troops on small, heavily defended islands. Both operations depended entirely on landing craft, performing flawlessly under sustained combat conditions. And both operations succeeded largely because the Higgins boat did exactly what it was designed to do. The statistics from Okinawa are particularly revealing. Over 1,800 Higgins boats participated in the operation. They made over 50,000 individual beach runs between April and June 1945. Despite operating under kamikaze attacks, artillery fire, and some of the worst weather conditions of the Pacific War, the boats maintained an operational readiness rate above 90%. The simplicity and ruggedness of the design had proven itself under every possible condition. When the war ended in August 1945, Higgins Industries had produced over 20,000 LCVPs and several thousand LCM-3 seconds. Licensed production from other yards brought the total to over 23,000 landing craft of Higgins design. These boats had participated in every major amphibious operation of the war, from North Africa through Sicily, Italy, Normandy, southern France, and across the entire Pacific theatre. The strategic impact was incalculable. Without the Higgins boat, D-Day would have been impossible. Without D-Day, the war in Europe would have lasted years longer and cost millions more lives. Without effective landing craft, the Pacific campaign would have required either a negotiated settlement or the use of atomic weapons on a much larger scale. The Higgins boat didn't just support amphibious operations. It made them possible at the scale required to win the war. General Dwight Eisenhower, in his post-war reflections, called Andrew Higgins the man who won the war for us. Eisenhower elaborated, "If Higgins had not designed and built those landing craft, we never could have landed over an open beach. The whole strategy of the war would have been different. We would have been forced into a different approach, probably through the Mediterranean, which would have delayed victory by years." The Higgins boat was as critical to victory as any weapon system we deployed, including the atomic bomb. Admiral Chester Nimitz, commander of Pacific forces, was equally direct. The war in the Pacific was an amphibious war. Without the landing craft designed by Higgins, we could not have fought that war. It's that simple. Every island we took, every advance we made, depended on putting troops ashore from those boats. Higgins didn't just contribute to victory. He made victory possible. Andrew Higgins himself remained characteristically modest about his role. When asked about his contribution to the war effort, he typically responded with practical observations rather than grand statements. "We built boats," he would say, "good boats that did what they needed to do. The boys who sailed them and the men who rowed in them won the war. We just gave them the tools." But the numbers tell a more complete story. 23,000 landing craft, over 20,000 workers employed at peak production, millions of troops delivered to hostile shores, hundreds of millions of tons of cargo landed across beaches. The entire Allied strategy for winning World War II had rested on the foundation of a simple plywood boat designed by a loud-mouthed boat builder who had never finished high school. The Higgins boat represented something fundamental about American industrial capability during World War II. It wasn't the most sophisticated weapon. It wasn't the most powerful or the most technologically advanced. It was simply a tool designed to solve a specific problem, engineered for mass production and built in quantities that overwhelmed any opposition. The same philosophy that produced Liberty ships, Sherman tanks, and P-51 fighters had produced the Higgins boat. Simple, rugged, good enough, and available in unlimited quantities. The post-war era saw most Higgins boats quickly scrapped or sold as surplus. The Navy had no peacetime use for thousands of landing craft. Many were cut up for scrap metal. Others were sold to commercial operators and converted for fishing or cargo hauling. A few were simply abandoned on beaches or in harbours, left to rot as their usefulness ended with the war. Higgins Industries itself did not survive the peace. The company's entire business model had been built around wartime production. When contracts ended in 1945, the company collapsed within months. Higgins tried to convert to peacetime production, including an innovative but commercially unsuccessful attempt to build aluminum boats. By 1946, the company was bankrupt. Andrew Higgins died in 1952, largely forgotten by a public that had moved on from wartime concerns. Today, fewer than 20 original Higgins boats survive in museums and private collections. The boats are now recognized as critically important artifacts of World War II, but for decades after the war, they were simply forgotten. The tens of thousands of boats that made D-Day possible, that island-hopped across the Pacific, that put millions of troops into combat, were discarded as obsolete equipment the moment their job was done. The story of the Higgins boat is ultimately a story about solving impossible problems through practical engineering and industrial determination. The Allied war planners faced a mathematical impossibility. They needed to move armies across water and put them directly into combat at a scale never before attempted. Traditional methods wouldn't work. Traditional equipment was inadequate. Traditional thinking led to failure. Andrew Higgins provided the solution not through genius or innovation alone, but through a willingness to ignore conventional wisdom and focus ruthlessly on what worked. His boats looked crude to naval architects. They violated established design principles. They used truck engines and plywood and simple mechanical systems. But they worked. They worked in Louisiana swamps, they worked on Omaha Beach, and they worked on every Pacific island where American troops landed. The lesson extends far beyond landing craft or even beyond World War II. When faced with impossible challenges, the solution often lies not in sophistication, but in simplicity. Not in perfect design, but in good enough design that can be produced in overwhelming quantities. Not in elegance, but in ruggedness and reliability. The Higgins boat won the war not because it was the best possible landing craft, but because it was good enough and there were thousands of them. In the end, the Higgins boat represents the ultimate expression of American industrial power during World War II. It was a tool built to do a specific job, engineered for mass production, and deployed in quantities that made victory inevitable. The boats themselves were ordinary. The men who built them were ordinary. The crews who operated them were ordinary. But together, they accomplished something extraordinary. They made possible the liberation of Europe and the defeat of Japan. They turned the tide of the largest war in human history. They proved that sometimes the simplest solution is the most powerful. And it all started with a loud-mouthed boat builder from Nebraska, standing in a small shipyard office in New Orleans, reading a telegram from the Navy, and thinking about how to build a boat that could drive right up onto a beach and drop a ramp. Everything that followed, from D-Day to the Pacific, victory, came from that moment and that decision. The Higgins boat changed warfare, changed history, and proved that sometimes the most important innovations are the simplest ones. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today.